Good morning once again. Today we continue with integration, lesson 4. In our previous lesson, we were finding the area under a curve. We looked at both definite and indefinite integration. I hope you did the assignment that I gave you, and I hope you also practiced more on how to get the area under a curve. Remember, we said that it is important to sketch a curve before you get the area. So today I want us to see how you can find the area between two curves. You're going to use two methods, and after you use the two methods, it will be on your side now to choose which method you find easier. Now, I have written a question here. Find the area between the curve y is equals to 4x minus x squared and the line y is equals to a half x. When a question is posted that way, it means you find the exact area by integration. So I have sketched that curve, or the two. One is a curve and the other one is a line. And the area we need is this one here. That's the area that we need. We need to know the points of intersection between the line and the curve. So that is step one. Getting the points of intersection. So it means we have y is equals to 4x minus x squared, the curve, and y is equals to a half x, the line. At the point of intersection, then that point must satisfy these two equations. So it means we solve these two equations simultaneously. We may not require the value for y here because we are integrating using the values of x. So we need to know this value of x and this other one where these two intersect. So let's equate the curves. 4x minus x squared is equals to a half x. So we bring this a half x to this side. We will get 3.5x, that is 3.5x, minus, let me write that as 7/2. 7/2x minus x squared is equals to 0. Factor out x, you get 7/2 minus x is equals to 0. So either x is equals to 0 or x is equals to 7/2, which is 3.5. So we are going to integrate between x is equals to 0 and x is 3.5 because these are the points of intersection. So this one here is 3.5 and this one is 0. From here, we can take two routes. I'll look at both, then you pick one, which will be easier for you. Method 1. We can get the area between x is equals to 0 and x is equals to 3.5 for the first curve. That is the whole of this area, including the one which is unshaded here, including that one. Then we also get the area under the line for the same limits under the line. And then for us to get the area we want, we subtract. The area under the curve between x is equals to 3 and x is equals to 3.5 will be that one, the whole of this area. All of it. Then the area under the line will be this one. So when we get the complete area minus the area under the line and we subtract, we will be left with the area that we want, the shaded part. So that is method number 1. Let's go through it. So we are going to integrate 0 to 3.5, that is 7 over 2. 4x minus x squared with respect to x. And here we are going to get 2x squared minus x cubed over 3, 0 to 7 over 2. So I would like you to substitute 7 over 2 here, and then you substitute 0. Of course, I have not included the constant. Because for definite integration, it is not compulsory for you to include the constant, simply because when you subtract, after you substitute here now, you will get a 0. C will be 0. And in any case here, you only need to substitute x is equal to 7 over 2 here, because when you substitute x is equal to 0, you will still get a 0. So when you substitute 7 over 2 here, you will get 2 multiplied by 49 over 4 minus 7 cubed, 7 over 2 cubed over 3. I want you to complete that part. And as you complete it, do not put a decimal here. Because as you put that decimal, you will be forced to estimate somewhere. You might be forced, as you get 3.5 cubed, you will get a long number. But when you get 7 over 2 cubed, you will get a fraction, a number which is a fraction. Remember here we are getting the exact area. We are not estimating the area. So get the area as a fraction in this case. Then substitute the other one now. From x is equal to 0 to x is equal to 7 over 2. We integrate a half x with respect to x. So integrate this again, you get x squared from 0 to 7 over 2. So substitute that again, you get 49 over 4. Don't leave it in decimals, let it be like that. So the answer you get here, in the first case, subtracts 49 over 4, and you will get the exact area. You can pause and get the exact area. Tell us what you find. The second method in the second method, remember when we were solving and getting the points of intersection, I deleted that. We were solving y is equals to 4x minus x squared and y is equals to a half x simultaneously, so that we get the equation or the point of intersection and where we are going to integrate from, our limits. So when we equated these two, 4x minus x squared is equals to a half x. We brought this a half x to this side. We got 7 over 2, that is 4x minus a half x, you get 7 over 2x, that's 3.5, minus x squared is equals to 0. This equation that we get after we have substituted, we can use it to integrate. It is the space which is in between those two lines. This equation gives us the space in between the two lines, in between the two curves, or between the curve and the line. And we integrate it directly. This one does not require you to subtract anything. You just integrate from 0 to 7 over 2. We integrate 7 over 2x minus x squared with respect to x. I would like you to integrate this one directly, get the answer. Don't put any decimals, use fractions, and compare the answer you get here with the one you got in method 1. You will find out that here you get the answer directly without requiring to subtract. Why? Because you have already subtracted here. The subtraction is taking place at the point of equations. So you are integrating what you have gotten after you have subtracted. This one is a direct method. It doesn't mean it is the best, though it will always work. You can choose which method you are going or you are comfortable with and apply any in the assignment that will come. So do more practice and perfect your skills. Have a nice day.